All right, how's everyone doing? We've got a gap in the middle of the room now. Yeah. Any questions on the programming assignment? I have hours tomorrow morning at 9, but that's pretty much it until the assignment's due. So this would be a really good time to hit me with all those questions.
What kind of punctuation would you like to accept?
Anything. Although I won't test it with a comma because it makes the output look goofy. But any character the person inputs other than white space is an element of the set.
Did you say there was some kind of limit on how many characters?
120 characters of input, which means the set they input can't have more than 120 elements, which means the union can't have more than 240. But there aren't that many characters they can type.
Is it all right if I made my array bigger than 128 for their input?
Sure.
Okay, so
How big did you make it?
really big.
How big?
My head did like 600s, 1000s.
Six-
I don't know why.
I think I've seen you do that. Yeah, that's okay. As long as it compiles, that'll be good. Other questions?
How do we use is space?
So grab it from C type. And you can just say if is space. Where C is a character, yeah. And that'll pick up a regular space, a tab, a new line, a vertical tab, all those things.
Yeah, it returns 0 and isn't, but returns like whatever else it is.
Right, so you can throw it in an if statement like that, or you can say if it's 0 or if it's not 0. And that's the only special handling you want to do on the input. Don't convert to uppercase or lowercase or anything like that. Just take each character. It's a member of the set. Don't need to what? Nope. Yeah, the order doesn't matter. Everyone good? All right. So let's keep talking about sequences. So remember, a sequence intuitively was something like this. It was a set of elements separated by commas, and they occur in a certain order. And unlike a set, we could have repetition. For example, this is another sequence. So 1, 0, 2, 0, 3, 0, 4, 0, and on and on. And I made the comment that we can view a sequence as a function. So it can be a function from, say, the set of positive numbers to some set S. And in this case, S could be the set of integers. And so this sequence could be defined by the function f of 1 equals 1, f of 2 equals 0, f of 3 equals 2, f of 4 equals 0, f of 5 equals 3, f of 6 equals 0, and so on. And the idea is, if you apply f to consecutive positive integers, 1, 2, 3, 4, 5, 6, you get the collection of elements in that sequence in the order of the sequence, 1, 0, 2, 0, 3, 0, and so on. And so we could define this in general as a set of elements a sub n, where a n is just f applied to n. Yes?
In general, do we start the sequence with f of 1 or
Doesn't matter. Doesn't even have to be positive. It could be any subset of the integers. In general, I'll be inconsistent though. And so we use a kind of unfortunate notation for the sequence, which is to write a sub n inside curly brackets. And that represents the sequence. A1, A2, A3, A4, and so on. And this is bad notation. Let's say this is poor notation, but it's what we use anyway. So when you see in the context of sequences, curly bracket AN, it's not a singleton set anymore. It's not a set at all. It's a shorthand for representing a sequence, which is the collection of AN in order. And so, for example, this function f for 1, 0, 2, 0, 3, 0, 4, 0, and so on could be written as f of n equals one of two things. So it equals 0 if n is even. And if n is odd, it looks like n plus 1 over 2 if n is odd. So f of 5 would be 5 plus 1 over 2 is 3. So one way to describe a sequence is to write a formula for each term of the sequence. But there's other ways of defining sequences. So if an equals 1 over n, where n is bigger than or equal to 1, then we have a sequence 1, 1/2, 1/3, 1/4, and so on. If we had a sequence an equals r times a to the n, sorry, let's do a times r to the n. Then a1 equals a times r, a2 equals a times r squared, a3 equals a times r cubed, and so on. So your sequence is geometric. And if you look at this particular sequence, let's forget about a. Let's just make a equal to 1. So let's just have a sequence which is, I don't know, let's have r. So it could be r, r squared, r cubed, r to the 4th. Right, so in general, a sub n is r to the n. But we have another way of describing the nth term of a sequence. We could actually say an. Well, what's the relationship between this term and this term? Say again? Yeah, so this is this term times r. And this fourth term is the third term times r. and the third term is the second term times r. And so in general, we could say n equals r times a n minus 1. And that's only valid for n bigger than 1. So assuming this is a1, a2, a3. But we can't use this formula to find what a of 1 is because it says it's r times a0 and there is no a0. Or maybe there is, but then we'd need to know what a minus 1 was, and so on. So we have a special condition here where we could say a1 is equal to r. And this completely defines the sequence just as well as this does. So this is a formula. You plug in n and you get the nth term of the sequence. This is a different kind of formula. If we want to know what A5 is, this formula doesn't automatically tell us what A5 is. It describes A5 as a function of A4. And we can't use this formula to find the value for A4. We can only find a relationship between A4 and A3. So this is called a recurrence relation. And we're going to work a fair amount with recurrence relations. Oh, there's our drill. That's a lockdown drill. Hey, you want to lock down in our room? Guess we're supposed to close those windows too, so if someone wants to do that. The sniper up in the trees. And we're supposed to be quiet, so I'm not going to lecture. But I'm going to stop my recording.